And we're asked to find the nth term of an arithmetic sequence. First thing I want to do is, really I want to make sure that this is an arithmetic sequence. If I get, let's call this the 5 there, let's call that the first term. And to get to the second term, which is the 9, that's the second term. To get to the second term, we add 4. Now, to make sure that it's an arithmetic sequence, does that pattern continue right here? To get from 9 to 13, yes, I see that we add 4 to get to 13. Okay, then I want to check that throughout. 13 to 17, yes, add 4. All right, so that looks like the pattern, is we're going to add 4. So if 5 is the first term, 9 is the second term, 13 is the third term, the question is, this term right here, this term can be, it could be the 20th term, the 30th term, the 50th term, whatever. It generically speaking, it is the nth term. Okay, so what we're going to do is we're going to look at the term, and we're going to look at the value of the term and how to calculate it. Okay, so the first term is not real exciting. It's just simply 5. And we're going to come back to that in a minute. But the second term is a little bit more exciting. It is start at the first term, which is 5, and then we add 4, because that's the pattern. The question is, how many times do we add 4 to get to that second term? Well, we only added 4 one time. And let's see if that is correct. Well, 4 times 1 is 4, then add 5, that is 9. And yeah, that works out just fine. Okay, now what about the third term? The third term, well, we start at the first term, which is 5, and we add 4 how many times? Well, to get to that second term, we added 4 one time, 2 times. So we add 4 2 times. And let's check and see if that's right. 4 times 2 is 8, plus 5 is 13. And yep, that works to get us to the third term. What about the fourth term? Well, let me see. We start at the beginning. We start at the first term, which is 5, and we add 4 how many times? Well, we add 4 3 times to get to the fourth term. And that is, well, 4 times 3, that's 12, plus 5 is 17. And lo and behold, that is correct. Okay, so really we want to look at the term itself, in this case the fourth term, and that tells us how many times to add 4. So the fourth term, we add 4 3 times. Well, that's interesting. Okay. Let me see. The third term, what did we do? We started at the beginning and we added 4. Hey, 2 times, only 2 times. So this number right here, the term is what tells us how many times to add that difference. Okay, so now we're going to go very abstract. What if I'm looking for the nth term? I haven't given it a number. It's just n can be anything. So what do? We continue with that pattern. Hey, we start at the first term, 5. Then we add 4. How many times? Well, the pattern is this number minus 1. So it's n minus 1. That's how you calculate the nth term. Okay, so now what if I asked you to find the 21st term? Let's find find the 21st term. Well, okay, so that's telling us right there that n equals 21. So if I want to find the 21st term, then here's how I'm going to calculate it. I'm going to start at the first term, which is 5, and I'm going to add 4. How many times? Well, this right here tells us how many times. It is 21 minus 1, n minus 1. Okay, so that is 5 plus 4. How many times? Well, 21 minus 1 is 20, and that is 5 plus 4 times 20 is 80, and that is 85. Okay, so the 21st term, if I bounced along out here and got to the 21st term, then it would be 85. And if you are curious, I would suggest that you write these numbers down and bounce along there, add 4, 19 or 20 times, and see if you don't come up with 85 as a result. But that's how you do it. This equation right here will never change if you have an arithmetic sequence.
Finding the 21st term in the following sequence, 7, 10, 13, 16, 19, and so on. Go ahead and look at our sequence and find our pattern first. What it takes to get from 7 to 10, 10 to 13, 13 to 16, and so on. And we see that our pattern is increasing by 3. That means 7 plus 3 is 10, 10 plus 3 is 13, 13 plus 3 is 16, and so on. So we're finding our nth term. For that, we're going to need the first number in our sequence. In this case, it is 7. We're going to add 3 because our sequence is increasing by 3. We're going to multiply that by our nth term minus 1. Now, in this case, we know the nth term we're looking for is the 21st. So we'll go ahead and plot that in. 21st will be equivalent to 7 plus 3 times 21 minus 1. Let's go ahead and simplify that. 7 plus 3, 21 minus 1 is 20. And we'll work that out. 7 plus 3 times 20 is 60. 60 plus 7, 67. So that means that by the time we plot it in, and we get to our 21st term, the number on our sequence is going to be 67. Finding the 31st term in the following sequence, negative 8, negative 3, 2, 7, 12, and so on. We're going to go ahead and look at our sequence and find our pattern, what it took to get from negative 8 to negative 3, negative 3 to 2, 2 to 7, 7 to 12, and so on. In this case, we see that 5 was added. Negative 8 plus 5 is negative 3. Negative 3 plus 5 is 2. 2 plus 5 is 7. 7 plus 5 is 12. And we're looking for our nth term. In this case, we're going to have nth would be equal to, we're going to borrow our first number from our sequence, which is negative 8. We're going to add 5 because that's what's being added each time. And we're going to multiply 5 by our nth term minus 1. We know that the nth term we are looking for is the 31st, so we're going to go ahead and plot that in. 31st term would be equal to negative 8 plus 5 times 31 minus 1. I'm going to go ahead and simplify that. Negative 8 plus 5 times 31 minus 1 is 30. Work that out a little further. Negative 8 plus 5 times 30 is 150. And negative 8 plus 150 is going to equal 142. What this tells us is that by the time we plot it in and we get to our 31st term, our number is going to be 142 in our sequence. Finding the 31st term of the following sequence, 24, 20, 16, 12, 8, and so on. So we're going to look at our sequence and try to find our pattern. That means what does it take for us to go from 24 to 20, from 20 to 16, from 16 to 12, and so on. In this case, if we take 24 and subtract 4, we're going to have 20. 20 minus 4 will give us 16. 16 minus 4 will give us 12, and that will continue. But we're interested in finding our 31st term. For that, we're going to need our nth equation. Nth will equal, we'll borrow our first number in our equation, that'll be 24, and minus 4, because our sequence keeps decreasing by 4, times the nth number minus 1. Now we know we're trying to find the 31st term, so go ahead and substitute that for our nth number. 31st term is going to equal 24 minus 4 times 31 minus 1. Go ahead and work that out and simplify it. It'll be 24 minus 4 times 31 minus 1 is 30. We'll work that out. 24 minus 4 times 30 is 120. And 24 minus 120 is going to give us a negative 96. So our 31st term is going to be negative 96. That means if we keep plotting in the numbers, by the time we get to our 31st term, our sequence will be at negative 96.